us look at direct product of groups. So basically here we have two groups, and when we take the direct product of those two groups, we get a new group. So let's see what this means. Given two groups N and H, direct product G is equal to N times H. Here G is a new structure. Every element of G is in the form N comma H. It's an ordered pair where N is in the group N and H is in the group H. The operation is ordered pair N1 comma H1 times ordered pair N2 comma H2 is equal to the ordered pair N1 times N2 comma H1 times H2. So elements of N and H do not interfere with each other. As you can see here, N1, N2 have nothing to do with H1 and H2. And similarly, H1 and H2 have nothing to do with N1, N2 product. So they do not interfere with each other. Now, the new structure G forms a group. So let's briefly see the axioms. Closure property, product of two pairs is again a pair in G. Associativity, since multiplication in N and in H are associative, that means it is also associative in G. So here N2 comma H2 times N3 comma H3 times N1 comma H1 is equal to N1 comma H1 times N2 comma H2 times N3 comma H3. So it is associative. Now identity, the ordered pair of the identities of N and H acts as identity. So we have any element of G, that is the ordered pair N comma H, times the identity element of G, that is E sub N comma E sub H, is equal to N comma H, which is equal to the ordered pair E sub N comma E sub H times N comma H. And inverse, each element N comma H in G has inverse N inverse comma H inverse in G. So pretty abstract, right? So let's look at an example. So let's say N is Z3, that is integers under addition modulo 3. So the set will contain 0, 1 and 2. And let's take H is equal to Z2, that is 0, 1 under addition modulo 2. So G will be equal to Z3 times Z2, the direct product. Now the elements are all ordered pairs. So A in Z3 comma B in Z2 is equal to 0, 0, 0, 1, 0, 2, 0, 0, 1, 1, 1, 2, 1. Operation, as we have seen here, if we take A1 plus A2 from Z3, mod 3, remember this is mod 3, comma B1 plus B2 mod 2. So you can take any of these and work it out. Let's say 1 plus 2, that is 3. 3 mod 3 is 0, right? 1 plus 1, 2. 2 mod 2 is 0. So that means this will give us for these two elements 0, 0. Now, since Z2 and Z3 are abelian, G is an abelian. So the direct product would also be abelian. So let's take an example. Let x equal to 1, 1 and y equal to 2, 0. X plus y is equal to 1 plus 2 mod 3, comma 1 plus 0 mod 2. This gives us 3 mod 3, and this gives us 1 mod 2, which is equal to 0, 1. Now let's take y plus x. That gives us 2 plus 1 mod 3 and comma 0 plus 1 mod 2. So this becomes 3 mod 3 and this becomes 1 mod 2, that is 0, 1. So again, here also you can see that in both cases we are getting 0, 1, whether it is x plus y or y plus x. Since that is equal, direct product is abelian. Of course, this is not the proof. You literally have to add up all the pairs 2 by 2 and show that it doesn't matter in which order we add them. Okay, so now let's draw the Cayley's table for this. So here you have 0, 0, 1, 0, 2, 0, 0, 1, 1, 1, 2, 1. Same thing here. And when we take their products, since it is additive groups, additive operations, we are adding. So 0, 0 plus 0, 0 is 0, 0. 2, 1 plus 2, 1. That gives us 2 plus 2, that is 4. 4 mod 3 is 1. And 1 plus 1 is 2, that is 2 mod 2 is 0. So we get 1, 0. In Z3 times Z2, that is a direct product. GCD of the orders is equal to 1. That means they are relatively prime. So hence Z3 times Z2 is isomorphic to Z6. So basically what we have achieved is, given two groups, we have combined them and formed a new group. So that was direct product of groups. Again, let me remind you, there is a link to a PDF book which describes all these in detail. Please feel free to download it, refer to it. And if you think somebody else can also benefit from it, please do share. That's it for now. Bye.